The floor is yours. What questions do you have? 6-4, 6-5? Or the review sheet for the final? Talk to me. Want to be a short day, illustrate. Yes. Same area.
Like the entire window of the find that the area thing or just the one that belongs to the
I'm not sure what you mean by just the ones that the lines create.
average one.
Okay. So yes, I want the function between the two pieces, and then I want the graph created by your average value on the same set of axes. So the example we did at the end of class yesterday was this one. And yeah, I'm looking for a picture that looks like this. No, I just need you to show me that this rectangle and this thing have the same area.
Okay.
So this whole rectangle here should have the exact same area as the area under the curve. But by the mean value theorem for integrals, as soon as you find the average value, that's the number you found. This whole rectangle should have the same area as the entire area under the curve. Or the area above should be equal to the area that's deficit. In geometry, classical Greek geometry, you talk about finding an area of something given, either with a certain amount of excess, hyperbole, or a certain amount of deficit, parabole. Oh, sorry, elliptus. And thus we get hyperbola and ellipse for over and under an exact match. So we have hyperbolic area and parabolic area and the area over the area under. I love the way that those terms drifted from geometry to trig and conic sections because they were measuring against curvature. And there's a really interesting piece of geometry, readings in mathematics, SMA 240, history of math. Yes, ma'am. 6.5, number 4. What? I think that's probably the easiest way to use it. Well, but E is a number there, right? If I'm thinking of the function f of z equals e to the 1 over z squared, I am thinking of that as like the e to the x, where we treat e as a number. But what did you mean by treating e as a number there? So how did we do this integral? Well, that's unfortunate because that means that that's not calculus. It's Avarius, and I'm very happy to see you're inventing your own new book, and we look forward to its publication, but no. As a student a number of years ago, his last name began with an M, and routinely would say, well, if I made the rules, I wouldn't have done it that way. I said, I keep looking forward to your Malculus book. He hasn't written it yet. Then I thought about it, and I said, that means bad thing. I don't want to do that. Yeah, I'm gonna think of this as e to the stuff. I'm sorry? Well, wait a minute. Now, if I think of this as e to the stuff, then my u is usually the. If I think of e to the stuff, my u substitution is usually that piece. So let's rewrite this and put the e to the 1 over z out in front. What would I be left with? If I took the e to the 1 over z off the top of the fraction, what would I have as the fraction? And now I can see if I can find a u and a du when it's written like that. Yes, ma'am.
81615. Instead of like doing it like how you do that, or we allowed to plug it in, or do you want us to like?
I want to see all integrals should be done by hand unless explicitly asked to do it in your calculator. It's a calculus class, not a button pushing class. More than willing to teach button pushing. I charge a lot more, and we do learn a lot less. I am all in favor, though, Grace. I'm all in favor of you doing it in your calculator to check your work. I hardly agree with that. Yes, ma'am. So I'm going to ask it to do an integral, right? So on the graph, I can say second calculate. And one of the options there is an integral, right? And then I can give it, well, from where to where? In this problem, it was from 0 to 2. Notice that's not the average value. That's the actual area under the curve. To the nearest 1, 2, 3, 4, 5, 6, 7, to the nearest 100 millionth. But Math 9 does that on the home page, not on the graph. So I can do it here as well. I just need to then type in all the equations and stuff. So I could say, oh, I'm going to go from 0 to 2. Since I have the equation I want in y1, I could say, oh, use the, oh, I hit a button. There we go. I can say, oh, use the thing in y1 rather than have to type it all out again. And I'm integrating with respect to x. Look, I got the same answer. Good, my computer agrees with itself. I hope it agrees with me when I do this by hand. So yes, I can do this in the graph. I can do it on the home page. There are at least 2 other ways to type in an integral on here. Now, it depends on your syntax. If you hit math option 9 and you actually get the word FNINT, come talk to me. You have an older version of the software on your computer, and I will happily show you the syntax for typing it in, but you can still do it with that command. More questions?
The work problems, if we give the equations for force in terms of kx.
For a spring problem, I'll need a force equals kx somewhere. And I'll either need, I know that every spring uses F equals kx in some fashion for its force. So I either need information about a force and a distance, I think one of the problems says that we take our spring from 40 centimeters to 30 centimeters and we use a certain force. Well, I can use that to solve for the K involved. Then I have my force equation, and now I can figure out the work done to move the spring. Yeah, and usually I need to know what acceleration I'm either working against or working with. And I think in all of the other problems, I'm working against gravity. So if I'm in pounds, I don't have to do anything, but if I'm in kilograms, I need 9.8 meters per second squared thrown in there somewhere. Well, it depends on which way we're going, right? If I'm working to move a weight up, well, I'm working against gravity, right? How much work did I do? Does it matter what the direction is? So I can almost always assume it's possible. But what does it mean to have negative work done? A spontaneous reaction. Work is coming out of the system rather than me putting into a system, right? I take the object, I let it go. Work was done by gravity, not by me. And thus, if I want to capture that work, I send my falling object over a turbine and we have power from a water wheel. Yes, let us take advantage of the work that is already being done by somebody else. More questions? Yes.
For 1/10 are you only have to multiply by the value of gravity if it's given kilograms?
Or grams or whatever metric unit I'm working in. Because pounds already takes gravity into account. Pounds is already force. Kilograms aren't. They're mass. Well, technically, I could leave anything that derives from pounds, right? Like tons. But I just convert that to pounds and keep it as pounds most of the time. Very few people talk about, the ton foot as a unit of force. Pounds, yes, but not tons. Although there are other systems, right? Any system of measurement has to have these items to be able to describe this idea. Depending on when you read certain books, you may or may not think about the units of measurement. How far is it from the Shire to Mordor? They give the measurements in leagues. What's a league? No. A league is a military term. It's a matter of marching. A league is the distance an army can cover in a certain period of time. I wish I was making this crap up. That's a Roman definition. Measurements in England used to be given in rods. A distance of a rod. It was literally a physical stick. It was 6 foot long. A fathom, 6 foot deep underwater. Units are crazy. So I have to figure out what units I'm working and then figure out how to get them back to units I know. Who the hell came up with a gallon anyway? Pint. A crazy unit. Come on, why don't we sell ice cream in appropriate units, like kilograms? Come on, Nicolina, why won't Millie stop selling pints and quarts and start selling intelligent units? She's wearing her ice cream shirt. That's the only reason I didn't rag on her for this. The only reason I know to keep a pint is a pint of water weighs 1 pound. So a gallon is 8 pounds. It's the only reason I even bother to think about that. Well, that and the fact that I used to own a waterbed. I don't recommend moving from a city in which almost all of the apartment buildings have concrete and steel floors to a wood framed house with a waterbed. A king size waterbed is 6 foot by 7 foot by 8 inches deep of water. That's 2,200 pounds before you put my pudgy pink butt in it, and the wife and the dog. I crushed a beam in my house, 4 inches, damaged the flooring. Don't. Water is heavy. A lot of house repairs in that house. Anyhow, I've wandered well off topic. More questions? There's a units question on the review sheet.
What's up here, to explain or like justify was answers from the file.
If you're expected to explain something in a question, it will say explain. We did that in the first exam, right? We talked about, why is this continuous? Explain why this, or how do I know that? Yeah, there are some questions very similar to the stuff we've seen on the other exams like that. Yes, in the first exam, we talked about where, I'm sorry, either the first or the second. We talked about, is a function continuous at a particular point? I don't remember doing a question about inferring absolute values. If you can find it for me, I'll absolutely answer it, but I'm not sure I have one off the top of my head. We did a couple of limit questions that involved absolute values in the homework. That's way back in chapter 2 on the first exam review. There were things about absolute value, but coming from the left and coming from the right. But that was where we looked at our one-sided limits. When we do the antiderivative of 1 over x, we get the ln of absolute value of x. Yes. But that's the only other place our absolute value comes up and bumps on us and says, hey, remember me? Exam 3B. Those are the scans. Here we are, exam 3. This one? Well, this again is a question about knowing what the second derivative means, right? So yeah, a question like this with no numbers in it at all, tell me what the second derivative tells you about a point that is a critical point where the second derivative is, in this case, negative, or in this case, equal to 0. So this is a question that doesn't ask you to calculate something. It asks you to explain it. Show me you understand without any calculation. A number of years ago, I was told there were really 2 different pieces in calculus. There's, can I do the calculations? And do I know what the hell they mean? And this is more of the question of the second type. What does it mean when I do this calculation? I mean, back up here in part of question 2, you were asked about concave up and concave down. So here's a similar idea where I actually wanted you to do the calculation and tell me, where is this concave up? Where is this concave down? And now in the third question, I want you to apply what does being concave down tell me about a critical. So it's really a related concept, but yes, there are absolutely no numbers in this problem, which is annoying to a lot of people. And I like questions like this because I read English most of the time. Yes, ma'am. Okay, in this case, I know the first derivative is 0. I know the second derivative is 0. That means I don't know whether I'm concave up or concave down. The second derivative being 0 really tells me that graph is kind of flat there. Could it be a maximum? Sure, negative x to the fourth has a flat spot at 0. The first derivative is 0 and the second derivative is 0 there. X to the fourth has a minimum at 0. But the first derivative is 0, the second derivative is 0. X cubed has a flat spot at 0, but it's neither a minimum nor a maximum. So the second derivative test actually fails to give me any information. And that was one of the options in the question. Is it a maximum, a minimum, or are we unable to tell? In that case, I'm unable to tell. Because, and then I gave you actually all three of these options so you could look at the graphs and say, oh, yeah, there, oh crap, it could be any of them, couldn't it? So that's actually in our second derivative test, chapter 4, section 3, I think. Yes, what second derivatives tell us about the shape of a graph is chapter 4, section 3. And our second derivative test is on page 302. If I have a first derivative being 0 and a second derivative that's positive, I have a minimum. If I have a first derivative being 0 and a second derivative that is negative, I have a maximum. Notice what's missing. If its second derivative is equal to 0, because then this is inconclusive. I even made funny faces at this point, right? If my second derivative is positive, I'm concave up, so I must be at the bottom. If my second derivative is negative, I'm concave down, so I must be at the top. And if my second derivative is 0, I don't know squat. I learned those in 1985. They've stuck with me ever since. That's 40 years, people. It lasts. Better? More questions? Yes, ma'am. Sure. Which one do you want to look at? Number 2.
Like, I was essentially plugging the values, the usage points into GW define X to find out if they're positive or negative, and then
I'm plugging points that aren't the inflection points. Yes. So that's what this chart here does, is it then says, oh, my inflection points were -4 and 2. So pick a value that's not. You don't have to do it factored. You can do it as one line. So if you've done that, you would only see this. Yes, absolutely. I write them factored because I already had the thing factored up here. So, hey, 12 is always positive. X plus 4 changes once. X minus 2 changes once. I'm good. Now just multiply down. Positive times negative is positive, and so on. But if you plug directly in, you'll just get this bottom set here. It is exactly the same. I can do the same thing up here for the first derivative. If I was asked to make a sign chart for f prime to find increasing or decreasing. I think there was a question later that asked about that. No, I guess I didn't on this exam. Right, because I thought that was too big and I broke it up into pieces instead. But if I make a sign chart for f prime, I can do it factored or I can do it in one line. More questions?
Can you do a question similar to that one where you have to get a comfort me?
Okay. Let's take a look at problem 19. Problem 19 says I have a bucket. The bucket weighs 10 kilograms. It is lifted from the ground to a height of 12 meters. At a constant speed with a rope that weighs 0.8 kilograms per meter. Initially, the bucket contains 36 kilograms of water. A heavy bucket. But it leaks at a constant rate and finishes draining just as we get to the top. How much work is done? Okay, I'm moving a mass. In kilograms, I'm going to need gravity at some point. I can do it, multiply the 9.8 through all, or I can wait till the end and then multiply 9.8. But I'm going to need this 9.8 somewhere. Force is mass times acceleration. The acceleration is gravity, but the mass is changing. And since I'm going to do this by distance, because work is force times distance, I need to write how my mass is changing in terms of the distance covered. Okay, wait a second. I'm going from a height of 0 to a height of 12. That'll be my X measurement. I start at 0, pull up the bucket on the, okay, up we go. If I'm doing everything in terms of X, then I need to know the weight in terms of X, the mass. So it starts as 46 kilograms when we're at the bottom. Plus there's the rope, right? So I need to think about what's moving. We did the rope like the cable the other day. So I'm going to think of, that says 0.8 kilograms per meter. And a slice of the rope has to go up. So this piece of rope that's right here at the bottom is going to go a full 12 meters. But a piece that is at some height, let's say a piece of rope here, at a height of X, how far is it going to move? No, that's the piece of rope itself. The piece of rope will have width, delta X, but it's going to go up to there, isn't it? That's a distance of 12 minus X. And the weight of that piece of rope is 0.8 kilograms per meter times the number of meters for that piece of rope. So if I think about just the rope moving, I have to add up all of those. So for the rope, I'm going to get the integral from 0 to 12 of 12 minus x times 0.8 dx. That's just for the rope. Now let's think about the water. I start with 36 kilograms of water. But as I go up, I lose all the water by the time I'm up there. If it's leaking at a constant rate, how much water did I lose per meter of travel? 3 kilograms per meter, right? So I'm going to say, oh, I start with this much weight in the bucket, and I lose that much for every meter I go up. So that's the mass of the bucket, right? Okay. I have the mass of the rope in the first integral. I want force, I should multiply by 9.8. So in this upper integral, the integral from 0 to 12 of 12 minus x times 0.8, there's gravity for my force dx. There's my rope. And now the bucket and the water. I forgot it again. Put in the 9.8 there. But notice in both of those integrals, I could take the 9.8 and put them out front. So I could do the whole integral and then multiply by 9.8 if you wanted. Notice that if the bucket wasn't leaking, I'd move 46 kilograms the whole way, then I wouldn't have to do anything except multiply, wouldn't I? Because I'd be integrating a constant. But this bucket leaks. The rope and the bucket done separately. I think that's the easiest way. Now, in our problem for 18, we have a rocket full of fuel, right? So I can think of the rocket leaking the fuel, but I don't have a rope to worry about. So I really basically just do this part of the problem. By the way, this is about your rocket. The actual empty bottle here that I am holding weighs just about a pound, 450 grams. And it holds 750 mil of water. That's 0.75 kilograms of fuel. Here's your rocket. One of the things we are not taking into account in that problem, for which you should be very thankful, is that it says the rocket moves at constant speed. But really, when you light an engine, the acceleration is what's constant. And things that are lighter should move faster. So really, both the mass and the velocity should be changing at the same time, and that's much, much uglier. Chapter 9, Systems of Differential Equations, Chapter 9, Section 6. It's so cool. Guess what? You're really doing rocket science. More questions? The last edition of the book had the leaky bucket problem in pounds, which made it, quote, a little easier. We didn't have to multiply by 9.8. Yes, ma'am. Yes. So at the end of class yesterday, we were dealing with this problem, right? So we find the average value, which in our case is 26/9, by doing that for this function, right? So that's going to be the average value between 0 and 2. And when we do that, we get 26/9. Well, now I'm going to draw that horizontal line. Let me get rid of the shading part that we did earlier. There's my curve, and there's my box. So that's part B, I'm sorry, part C, where it says draw the rectangle, right? But now it says for part B, find where those two cross. Solving this by hand is a major pain in the neck in this problem. So I'll do it on the calculator instead, and I get 1.28. But if it is easy enough for me to do by hand, then I simply set the equation equal to the value and solve for x. In problem 9, I'm dealing with that equation, right? So I'm going to do 1/3 minus 1, the integral from 1 to 3, 1/t squared dt. That's a power rule integral. So I get minus t to the minus 1 from 1 to 3. Don't lose the 1/2 out front. Negative 1/3 minus negative 1/1. But subtracting a negative makes a positive. That gives me 1/2 times 2/3, which is 1/3. So now to solve for the value, I simply take 1/t squared and set it equal to 1/3. But I want only the positive one. I want the value that's between 1 and 3. So I cross multiply. I get t squared is 3. So I get t is the square root of 3. Because I don't care about the negative one that's not between the 1 and 3 that was the interval in our problem. One over x squared, square root 3, window, not from 0 to 2, but from 1 to 3 instead. What did I F up? What did I F up? Oh, I know what I F'd up. I'm not supposed to graph the square root of 3. I'm supposed to graph 1/3. Supposed to graph the average value. They'll cross at the square root of 3, which should be here somewhere, 1.7. Much better, 1.7. Second, calculate intersection 1.732, that's the square root of 3. Got to graph the right stuff. Sorry. Make sense now, Anna? Helps if you put the right pieces in the calculator. More questions? like 4. Well, I mean, this one is much like 4 because it's got that U substitution in it. But so does, wait, I need to look something up. In this folder. Somewhere, maybe. No, it isn't. What are the other problems for 6.5? Four, 8, and 10. Let's take a look at 6. 6 says x squared over x cubed plus 3 quantity squared. And our interval is -1 to 1. So our average value, 1 over 1 minus -1, integral from -1 to 1, x squared over x cubed plus 3 squared. So far, so good? I hate trying to do this like a quotient. I'm going to write it x cubed plus 3 to the -2, and then the x squared. Doesn't help if I don't write down the dx. Ugly to a power, I'm going to do a U substitution. So U should be which means the derivative of that is 3x squared. I don't have a 3 next to my x squared, so I'll get a 1/3. So now I have 1/2. I get this extra 1/3, u to the -2 du. Now you have a choice. Either I need to change the numbers, or I need to make sure I remember to switch back. Which would you rather do? Okay, so I'm going to go back to this substitution. If x is -1, then u is -1 cubed plus 3. What's -1 cubed? Add 3. If x is +1, u is 1 cubed plus 3. 1 cubed is 1. Add 3. I get 4. I don't ever have to think about x again. This problem is all in u. 1/6. What is the antiderivative of u to the -2? Negative u to the -1 power, or -1 over u? Evaluated from 2 to 4. So I get 1/6, -1/4 minus -1/2. Negative and negative becomes positive. So this is -1/4 plus 1/2, which is 1/4. So I get 1 over 24. Make sense? Other questions? This assignment is due on Monday. After class Monday, I will post the answers to those two homeworks and the key to the review sheet. If you have review sheet questions, you should look at that this weekend. Then you should come talk to me. You should have all gotten an email with this. This is what next week looks like. Monday is a normal class day, then all the schedule goes to heck. Our exam is 8 a.m. on Wednesday in here. You want to see me before then? There are my office hours. I will see you all on Monday. Have a wonderful weekend. Study hard.